So this is day 2 of our lessons, Wednesday, April 19th. And today we are going to solve the quadratic equations using the quadratic formula. So our agenda is to begin with the video lesson with quadratic formula. And then you will do independent work, which you can do with a partner. And then lastly, the exit ticket, which you will need to do by yourself. Okay. Or you can use your notes, but you definitely have to do it by yourself. The key term is discriminant, which is a part of the quadratic formula, and we're going to do another lesson on that later. So this is the formula, and you might recognize it. We haven't talked about it before, but it has been one of the formulas on the formula sheet on the RQA. So you notice here I have x equals a negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So this formula is very useful when we have an equation, a quadratic equation written in standard form. And our standard form is ax squared plus bx plus c, because I can identify, well, whatever number here would be my a term, whatever number is for b would be my b, and then whatever number I have here would be my c term, right? And I would just use basically substitution to solve this. All right, so now we have our first equation. Let's see, my computer's running slow. Here we go. So I have it right here. The equation or the formula that we're going to use, and here's my equation, and I'm just going to first identify what my a, my b, and my c terms are. So my a would be 1, b is a negative 5, and c I have a negative 14. So those are the three quote numbers I'm going to be using and substituting into this equation. So I have x equals, and I do the square root. I'm sorry, not the square root. I'll do my number, my line here. A negative, or the opposite of a negative 5. Right? So I do the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times a negative 14. Right? And you're wondering, where did I get these numbers from? I got them right from our equation, in which I put my values up here. And then on the bottom I have 2 times a, which is 1. Right? And so I want to start here. Well, the opposite of negative 5 is a positive 5, and I'll probably move this over. Right? And then I have plus or minus the square root of negative 5 squared. Well, negative 5 times negative 5 is going to give me a positive 25. And negative 4 times 1 is still negative 4. And negative 4 times negative 14. Negative 4 times a negative 14 would give me a positive 56. So I probably did a little step ahead. I knew I had a negative times a negative, and therefore I would get a positive. So I put a plus sign here, so I got a positive 56. Right? So then I divide that by 2, because 2 times 1 is 2. So now I want to add what's inside underneath my radical. And we've already identified this as the discriminant, or we haven't yet, but we will later on. So I want to add what's underneath my radical here. And so I have x equals 5 plus or minus, well, 25 plus 56 would give me 81, all over 2. All right, so I want to stop here to notice a couple things. One thing I noticed is that this plus or minus symbol tells me that I'm going to have 2 solutions, the potential to have 2 solutions. I'm going to have 5 plus the square root of 81 over 2, and 5 minus the square root of 81 over 2. So I'm going to rewrite this so I can show that I'm going to have 2 solutions. But before I do that, I want to take the square root of 81. In this situation, I know 81 is a perfect square, so the square root of 81 is 9. So I have x equals 5 plus 9 over 2. And I also have x equals 5 minus 9 over 2, right? Because I have two possibilities here with the square root of 81. I have a positive or a negative value. So here I have 5 plus 9 is 14, divided by 2 would give me 7. And here I have a negative 4 divided by 2 would give me a negative 2. So my two solutions here, or my two roots, my two x-intercepts, my two zeros, remember we're using all those terms, are 7 and x is equal to negative 2. So again, we're going to do the same thing as we did before. I'm going to identify my A, my B, and my C. So my A would be in this situation 1, because I have a leading coefficient of 1. My B is a negative 4, and my C is 4. And again, I have my formula. I'm just going to substitute those values into my formula here. So x is the opposite of negative 4 plus or minus negative 4 squared minus 4 times 1 times 4 over 2 times 1. All right, so I have negative 4 times, well, the opposite of negative 4, I like to think of it, or negative 1 times negative 4 would give me, either way, it's a positive 4, plus or minus, and let's do what's inside here. The under the radical, I have negative 4 squared is 16, minus 4 times 1 is 4, 4 times 4 is 16. So you probably already noticed something's going on here. And here I have 2. So as before, I have two solutions, the potential of two solutions. So x is equal to 4 plus the square root of, well, what is this? 16 minus 16 is 0 over 2. And x could also be equal, just to write it out, 4 minus the square root of 0 equals 2. Well, what is the square root of 0? It's 0. So in any case, I notice that this is not really going to impact it at all, because 4 plus 0 is 0 and 4 minus 0 is 0. So I would have one solution in both cases. 4 divided by 2 gives me 2, and 4 divided by 2 would also give me 2 here. So I have one solution, and that is going to be x equals 2. All right, so you notice now that I have a coefficient, or we have a coefficient that is larger than 1. We have 2 for A. So I have A equals 2, B equals 2, and C equals negative 12. Again, we're plugging those values back into our equation, or sorry, our formula here. So I have a B is 2, so I have a negative 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 12 all over 2 times 2. All right, and if again you're wondering where is she getting these numbers? I look first at my equation, I find my A, B, and my C, and I use those now to plug them back into the formula. So I have negative 2 plus or minus the square root of, well, I have 4 here, 2 squared is 4, minus, what is 8 times negative 12? That would give me a negative 96, but I'm going to say a negative, I can rewrite that as positive 96, because a negative times a negative is a positive, right? So I have negative 4 times 2 is negative 8. Negative 8 times negative 12 is positive 96. And then 2 divided by 2 is 4. Or 2 times 2 is 4, sorry. So now I have x equals negative 2 plus or minus, well, what is underneath my radical here? 4 times 96 is 10. I'm sorry, 4 times 96 is 100. And the square root of 100 is equal to 10. So I'm going to write 10 divided by 4. So I have two possibilities here, plus 10 or minus 10. So in fact, I'm going to write this one as x plus 10, or sorry, negative 2 plus 10 over 4, and x is equal to negative 2 minus 10 over 4. So here I would solve this one. I have 8 over divided by 4 will give me 2. And here I have a negative 12 divided by 4 would give me a negative 3. So our solutions are x equals 2 and x equals negative 3. So we have time to do one more. Okay, and here again our leading coefficient is still larger than 1. So I have a equals 2, b equals negative 3, and c equals negative 5. So I'm going to substitute those into my equation or my formula. X is going to equal negative 3, the opposite of negative 3, right? Because I have a negative 3 and this is a negative b, plus or minus the square root of negative 3 squared minus 4 times 2 times negative 5 all over 2 times 2. All right, so the opposite of negative 3 is going to be a positive 3, plus or minus negative 3 squared is 9, minus, oh, notice again, I'm noticing a negative 4 times a negative 5, right? So I know this is going to be a positive. So I have a positive 20 plus 2 or times 2, so that would give me a 40. And I put that all over 4. So I have x is going to equal 3 plus or minus the square root of 49 all over 4. Now, so far, these are all worked out really nicely, right? We're all perfect squares, and so we were just able to simplify that, just take the square root of the perfect square. So that's great. They might not always be as nice. So here I have x is going to equal 3 plus, well, what is the square root of 49? That is 7. And x is equal to 3 minus the square root of 49, which is 7, all over 4. Well, the square root of 49 is positive and negative 7 as well. I just want you to notice that. And so here, 3 plus 7 is 10 divided by 4. And 3 minus 7 is negative 4 divided by 4. Okay, so in this first situation, here, I can simplify it. I mean, I could probably write it as I'm going to continue to leave it as a fraction. So I can divide, let's see, 2 out of 10. So 10, and I'll just erase this to be a little bit more simple. Right over here. So I have x equals 10 over 4, and I'm going to divide 2 from both the top and bottom parts of that fraction. So I would have 5 here, and I have 2 here. So one of my solutions is x equals 5 halves. And the other one, well, that would be x is equal to negative 4 divided by 4 is a negative 1. All right, so these are the two solutions, roots, x-intercepts, zeros of this equation. So now I want you to complete your independent work. You can work with a partner on that, and then you complete the exit ticket independently. That means without anyone else's help. All right, talk to you soon.